Hello, in this lecture we'll answer on two questions. On the first question, we'll find out the area of the blue shape, and the second question, we'll find out the radius of this circle that blocks triangle ABC. So we'll start with the first question. In the drawing, we have the big circle. The area, we know that side A and B is the diameter of the big circle, and the radius of the big circle equals to 13 units, and the big circle blocks triangle ABC. The triangle ABC is inscribed by the big circle, and the small circle is inscribed by triangle ABC, and the radius of the small circle equals to 4 units, and we want to find out the area of the blue shape. Okay, so first of all, we will define the center of the small circle as O, and we will define the point of tendency of tangent CB with the small circle SM. We define the point of tendency of tangent AC with the small circle SM, and we will define the point of tendency of tangent AB with the small circle SL. Actually, we have rule number 1 that states that a tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we join points O and M together by a straight line. Point O is the center of the small circle. Point M is a point on the small circle itself. This is exactly the definition of a radius. That is to say, OM is the radius of the small circle, so we define the radius of the small circle as small r, and we know that small r equals to 4 units. So actually here, the radius of the small circle OM, it is 1 to the point of tendency. That is to say, it is 1 to point M, that is the point of tendency of tangent CB with the small circle. And whenever you have a radius that is 1 to the point of tendency, then tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO. It means that this angle equals to 90 degrees, and this angle will be equal to 90 degrees according to rule number 1. Likewise, we join points O and N together by a straight line. O is the center of the circle, and O is the center of the small circle, and is a point of the small circle itself. So this is exactly the definition of a radius. So OM is the radius of the small circle that is equal to 4 units. And we have the radius, here the radius ON, it is 1 to the point of tendency. That is to say, the radius ON, it is 1 to point N, that is the point of tendency of tangent AC with the small circle. And whenever you have a radius that is 1 to the point of tendency, then tangent AC will be perpendicular to the radius NO. So AC is perpendicular to NO. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. And we also have the rule that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. Here, peripheral angle ACB, this peripheral angle ACB rests on side AB, that is the diameter of the big circle. Therefore, it is equal to 90 degrees according to the rule that I mentioned. So actually, in quadrilateral ONCM, we have 1, 2, 3 right angles. So I write it down. In quadrilateral ONCM, we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually this angle MON. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle MON, equals to 360 degrees minus 270 degrees. It is equal to 90 degrees. So the missing angle MON, it is a right angle, it is equal to 90 degrees. So I can write here that this angle, it is a right angle. So actually we found out that in quadrilateral ONCM, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral ONCM as a rectangle. Okay. So quadrilateral ONCM is a rectangle because it has 4 right angles. We also know that the opposite sides of a rectangle are equal to each other, so the opposite sides of rectangle ONCM, they are equal to each other. That is to say, it means that ON equals to CM. ON equals to CM. ON equals to CM according to the rule that the opposite sides of a rectangle are equal to each other. But we already found out that ON equals to 4 units, so we can write here that ON equals to 4 units. And from this equation, 4 equals to ON equals to CM, we will derive that CM is also equals to 4 units. CM is also equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that OM equals to NC. OM equals to NC. According to the rule that the opposite sides of a rectangle are equal to each other. But we have already found out that OM equals to 4 units. It is the radius of the small circle. And from this equation, 4 equals to OM equals to NC. We will derive that NC is also equals to 4 units. NC equals to 4 units. And write down that NC equals to 4 units. In the next step, we will define side AC as A. That is to say here, AC is equal to A according to our definition. Side AC equals to A according to our definition. We define side CB as B. Yeah, CB equals to B also according to our definition. Yeah, side CB, this side, equals to B according to our definition. And we will define the diameter AB is C. So AB, the diameter AB equals to C according to our definition. Here, AB equals to C according to our definition. So, what is the length of side AN? From the drawing, it is very easy to see that side AN equal in its length to AC minus NC. Again, AC minus NC equals to AN. AC minus NC. AN equals to AC minus NC. That is to say, AN equals to AC equals to A according to our definition. And NC equals to 4 units according to what we have already found out. So, in conclusion, we found out that AN equals to A minus 4, so we can write here that AN equals to A minus 4 Likewise, we find out the length of line segment MB. What is the length of line segment MB? From a drawing, it is very easy to see that the length of line segment MB equals to CB minus CM. CB minus CM equals to MB. CB minus CM equals to MB. So MB equals to CB minus CM. So that is to say MB equals to CB. CB equals to B according to our definition. And we already found out that CM equals to 4. So in conclusion, we found out that MB equals to B minus 4. So we can write here that MB equals to B minus 4. In the next step, I will present to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. I repeat again, the lengths of two tangents from a common external point to a circle are equal. So we'll focus on the common external point, point A. For the common external point, point A, we have two tangents to the small circle. The first tangent is tangent AL, and the second tangent is tangent AN. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, AL equals to AN according to rule number 2. AL equals to AN. But we already found out that AN equals to A minus 4. So we can write here that AN equals to A minus 4. And from this equation AN equals to A minus 4, we derive that AN is also equals to A minus 4. AN equals to A minus 4. AN equals to A minus 4. So right here that AN equals also to A minus 4. In the next step, we will focus on the common external point, point B. For the common external point, point B, we have two tangents to the small circle. Tangent BL and tangent BM. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, BL equals to BM according to rule number 2. BL equals to BM. But we already found out that BM equals to B minus 4. BM equals to B minus 4. And from this equation, BL equals to BM equals to B minus 4, we will derive that BL is also equals to B minus 4. BL is also equals to B minus 4. You can write down that BL equals to B minus 4, so we actually found out that BL equals to B minus 4 and AL equals to A minus 4. And we know that AB is the diameter of the big circle. So here, AB is the diameter of the big circle. It means that AB is twice as long as the radius. So if the radius of the big circle equals to capital R, then AB will be equal to 2 times capital R. Okay, AB equals to 2 times capital R because any diameter is twice as long as the radius. So AB equals to 2 times capital R. It is given us in the question that the capital R, the radius of the big circle, equals to 13 units. So 2 times the radius, that is 2 times 13, will be equal to 26 units. So we actually found out that AB, that is the diameter of the big circle, equals to 26 units. That is to say, AB, that is equal to C, equals to 26 units. So actually, for one side, AB equals to 26 units. But from the other side, you can see from the drawing that AB equals to AL plus LB. AB equals to AL plus LB. We repeat again, from one side AB equals to 26 units, but from the other side AB equals to AL plus LB. But AL equals to A minus 4. We substitute AL by A minus 4, and LB equals to B minus 4. So we substitute LB by B minus 4. So in conclusion, we found out that according to equation number 1, 26 equals to AB equals to A minus 4 plus B minus 4. So So according to equation number 1, 26 equals to a minus b plus b minus a minus 4 plus b minus 4 is a plus b, and minus 4 plus minus 4 is minus 8. So in conclusion, we found out that 26 equals to a plus b minus 8. Here we will add to this equation number 1, 8, and we get that according to equation number 1, 26 plus 8 is 34, so 34 equals to a plus b. According to equation number 1, a plus b equals to 34. Here we will square this equation number 1, and we will get that according to equation number 1, a plus b squared equals to 34 squared. We squared both sides of equation number 1, and we get that a plus b squared equals to 34 squared. So here we will open the brackets on both sides of this equation number 1, and we get that according to equation number 1, a plus b squared equals to a squared plus b squared plus 2 times ab, that is equal to 34 squared, it is 1156. So according to equation number 1, we found out that a squared plus b squared plus 2 times ab equals to 1156. In the next step, we'll focus on the right triangle, triangle ACB. Triangle ACB is the right triangle because angle ACB equals to 90 degrees. For in the right triangle, triangle ACB or ABC, here by PT is the derivation for Pythagoras theorem, that the square of the hypotenuse equals to the sum of the square of the perpendiculars. So we get here the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, and the square of the hypotenuse is AB squared. And it is equal to the sum of the squares of the perpendiculars, that is to say it is equal to AC squared plus CB squared. So actually, I found out that according to the Pythagoras theorem, AB squared equals to AC squared plus CB squared. So actually, AB equals to C. So we substitute AB by C. So AB squared is C squared. That is equal to AC squared. AC equals to A, so AC squared is A squared plus CB squared. CB equals to B, so CB squared is B squared. So actually we found out that according to equation number 2, C squared equals to A squared plus B squared. C equals to 26, here C equals to 26, therefore C squared is 26 squared, so 26 squared equals to a square plus b square. So according to equation number 2, we found out that a square plus b square equals to 26 square, but 26 square is 676. So according to equation number 2, a square plus b square equals to 676. So we actually, because of the fact that a square plus b square equals to 676, it means that we can substitute a square plus b square in equation number 1 here by 676. We do it now and we get that according to equation number 1, here a square plus b square, it is equal to 676. So we substitute a square plus b square by 676. And here we have the equation number 1 plus 2ab equals to 1156. So according to equation number 1, 676 plus 2ab equals to 1156. Here we subtract from this equation number 1, 676. And we'll get that according to equation number 1, 2 times AB equals to 1156 minus 676 is 480. So we found out that according to equation number 1, 2 times AB equals to 480. Here we'll divide this equation number 1 by 2. And we get that 2 times AB over 2 is AB. And 480 over 2 is 240. So found out that AB equals to 240. Here we'll divide this equation number 1 by 2 again. And we get that according to equation number 1, AB over 2 equals to 240 over 2 is 120. So we actually found out that according to equation number 1, AB over 2 equals to 120. Okay. So what is the area of the blue shape? From the drawing, it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. I repeat again. Although drawing is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. That is to say, it is equal to the area of the triangle ABC. The area of triangle ABC equals to the base of the triangle, that is AC, times the height to the base, that is CB, over 2. Repeat again that the area of triangle ABC equals to the base IC times the I to the base, that is CB over 2 here. The height must create 90 degrees with the base, and indeed BC, that is the height, indeed creates 90 degrees with the base AB, because angle ACB equals to 90 degrees. So the area of triangle ABC equals to AC times CB over 2 minus the area of the small circle. The area of the small circle equals to pi r squared when r equals to 4 units. So in conclusion, we found out that the area of the blue shape equals to the area of triangle ABC, that is AC times CB over 2 minus the area of the small circle, that is pi r squared. So it is actually equals to the area of triangle ABC is AC. AC is A times CB. CB is B over 2. So the area of triangle ABC equals to A times B over 2 minus the minus pi r squared. R equals to 4, so r squared is 4 squared, that is 16. So the area of the small circle equals to 16 pi. In conclusion, we found out that the area of the blue shape equals to AB over 2 minus 16 pi. But we have already found out that AB over 2 equals to 120, so we substitute to AB over 2 by 120 minus 16 pi. So we actually found out, in conclusion, that the area of the blue shape equals to 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. I'll repeat again. The area of this blue shape equals to either 120 minus 16 pi square units, so in terms of numbers, it is equal to 69.73 square units. Okay, so we finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in 3 different methods. So here we have in the drawing this circle and triangle ABC is inscribed by this circle. We know that the area of triangle ABC equals to 9 square units. We also know that side AB equals to 5 units in its length, side BC of triangle ABC equals to 6 units in its length. And we want to find out the radius of this circle that blocks triangle ABC. So we'll start with the first method. So here we do a construction. From point A, we will draw perpendicular on BC. From point A, we draw perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. And then we will define the touching point of the perpendicular from point A and BC as D. We actually know that the area of triangle ABC equals to 9 square units. It is given as the question, so we can write here that the area of triangle ABC equals to 9 square units. But we also know that the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of this triangle, triangle ABC, will be equal to the base of the triangle that is BC times the height to the base. The height to the base is AD because it creates 90 degrees with the base over 2. So in conclusion, we found out that the area of triangle ABC equals to BC, that is the base, times AD, that is the height over 2. That is to say, the area of triangle ABC that is equal to 9 square units equals to BC. BC equals to 6 units according to what is given in the question. So it is 6 times AD over 2. So according to question number 1, 9 equals to 6 over 2 is 3, so 9 equals to 3 times AD. Here we divide this equation, equation number 1 by 3, and we get that according to equation number 1, AD equals to 9 over 3, that is 3. We found out that AD equals to 3 units. So here we can write down that AD equals to 3 units. In the next step, we will focus on the right triangle, triangle ABD. On the right triangle, triangle ABD, by PT is a version for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle, triangle ABD, it means that the square of the hypotenuse is AB, therefore the square of the hypotenuse is AB squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to AD squared plus BD squared. I'll repeat again. In the right triangle, triangle ABD, according to the Pythagoras theorem, we get that AB squared equals to AD squared plus BD squared. So actually, according to question number 2, here AB equals to 5 units, so AB squared is 5 squared, that is 25. And it is equal to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus BD squared. BD is the missing line segment, so we write it as it is BD squared. So, in conclusion, we found out that according to equation number 2, 25 equals to 9 plus BD squared. Here we'll subtract from this equation, equation number 2, 9, and we'll get that according to equation number 2, 25 minus 9 is 16, that is equal to BD squared. 16 equals to BD squared. Here we take a root from this equation, equation number 2, and we'll get that BD equals to the square root of 16, that is 4. So we found out that BD equals to 4 units. You can write down here that BD equals to 4 units. BD equals to 4 units. So what is the length of line segment DC? From the drawing, it is very easy to see that DC equals to BC minus BD again. BC minus BD equals to DC. DC equals to BC minus BD. So DC equals to BC. BC equals to 6 units according to what is given as the question. Minus BD. We just right now found out that BD equals to 4 units. So in conclusion, DC equals to 4 minus 6, that is 2. So DC equals to 2 units. And we can write down that DC equals to 2 units. In the next step, we will focus on the right triangle, triangle ADC. On the right triangle, triangle ADC, by PT is a version for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse in the right triangle ADC is AC. Therefore, the square of the hypotenuse is AC squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AD squared plus DC squared. AD squared plus DC squared. So in conclusion, we found out that in the right triangle, triangle ADC, AC squared equals to AD squared plus DC squared. So AC squared equals to AD squared. AD equals to 3. So AD squared is 3 squared, that is 9. Plus DC squared. DC is 2, so DC squared is 2 squared, that is 4. So in conclusion, we found out that AC squared equals to 9 plus 4, that is 13. So AC squared equals to 13. Here we'll take a root out of this equation and we'll get that AC equals to the square root of 13 units. AC equals to the square root of 14 units. So we can write here that AC equals to the square root of 13 units. In the next step, we will define the center of the big circle of this circle as O. And we will join points A and O together by a straight line. And then we'll extend line segment AO by a straight line until it touches the circle. And we'll define the touching point of the extended line segment AO and the circle as E. So line segment AE or chord AE passes from the center of the circle. Therefore, any chord that passes for the center of the circle is defined as the diameter of the circle. So AE is the diameter of the circle. AE is the diameter of the circle. So if we define the radius of this circle as capital R, then the diameter AE will be equal to twice as long as the radius. That is to say, AE will be equal to 2 times capital R. AE equals to 2 times capital R. Okay. In the next step, we will join points B and E together by a straight line. We actually created here angle ABE. This angle ABE, rests on AE, that is the diameter of this circle. And any peripheral angle that rests on the diameter of a circle is equal to 90 degrees. And because of the fact that peripheral angle ABE, this angle rests on the diameter of the circle, it is equal to 90 degrees. So this angle equals to 90 degrees according to the rule that I mentioned, is equal to 90 degrees. I'll write it down. That angle ABE this peripheral angle that rests on the diameter of a circle, of our circle, therefore it is equal to 90 degrees. Okay, we actually have another rule that says that peripheral angles that rest on the same chord are equal to each other. Peripheral angles that rest on the same chord are equal to each other. If we focus on chord AB, then on chord AB we have two angles that rest on chord AB. Angle ACB rests on chord AB, and angle AEB, this angle, also rests on the same chord called AB. And according to the rule that I mentioned, that peripheral angles that rest on the same chord are equal to each other, we will get that angle ACB equals to angle AEB. Angle ACB equals to angle AEB. Those two peripheral angles are equal to each other. Why? Because they rest on the same chord that is called AB. Okay. So if we define angle AEB as theta, so if this angle equals to theta according to our definition, then from this equation angle ACB equals to angle AB equals to theta, we will derive that angle ACB is also equals to theta. Angle ACB is also equals to theta. So here angle ACB also equals to theta. So actually, if you focus on the right triangle ADC, angle ADC equals to 90 degrees. Angle ACB D equals to theta. So this angle DAC must be equal to 90 degrees minus theta. In order to complete the sum of the angles in triangle ABC to 180 degrees, this angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees equals to 180 degrees. And here, the same thing is true in triangle ABE, the right triangle ABE. This angle equals to theta. This angle equals to 90 degrees, therefore this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle ABE to 180 degrees. This angle must be equal to 90 degrees minus theta. Okay, so in the next step, we'll prove that the right triangle ABE, this right triangle, right green triangle, triangle ABE, is similar to the right green triangle, triangle ADC. This right triangle, right green triangle, triangle ADC. Okay, so I write it down. We'll focus on triangle ABE, this right green triangle. And this right triangle, triangle ADC. So, why those two green triangles are similar to each other? First of all, those two angles, they both equal to 90 degrees, therefore they're equal to each other. So here angle ABE equals to this angle, that is actually angle ADC, and both angles are equal to 90 degrees, therefore they are equal to each other. I repeat again, angle ABE equals to angle ADC, and they are both equal to 90 degrees. In addition, those two angles, they both equal to theta, therefore they are equal to each other. So here this angle, angle AEB, is equal to this angle that is actually angle ECD, and they are both equal to theta, therefore they are equal to each other. Repeat again, angle AEB equals to angle ACD, and they are both equal to theta, therefore they are equal to each other. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So here, this angle, angle BAE, is equal to this angle that is actually angle DAC, and they are both equal to 90 degrees minus theta, therefore they are equal to each other. I repeat again, angle BAE equals to angle DAC, and they are both equal to 90 degrees minus theta. So I actually proved that all the angles of triangle ABE can go into all the angles of triangle ADC. Therefore, triangle ABE is similar, this is the sign of similar, to triangle ACD, according to angle similarity rule. Okay. And from the fact that the two rectangles are similar to each other, we will conclude that the following equation is true. We will conclude that AB over AD equals to AB over AD equals to AE over AC. I'll repeat again, from the fact that the two green triangles are similar to each other, we conclude that AB over AD equals to AE over AC. So actually, AB equals to 5 units, AD equals to 3 units, and it is equal to AE. AE equals to 2 times the radius of the circle, that is to say it is equal to 2 times capital R, over AC. AC equals to square root of 13 units. So in conclusion, I found out that according to equation number 3, 5 over 3 equals to 2R times square root of 13 units. Here we will multiply this equation by square root of 13 units. And we found out that according to equation number 3, 5 over 3 times square root of 13 units equals to 2R. Here we divide this equation number 3 by 2, and we get that the radius of this circle, the radius that we are looking for, equals to either 5 times square root of 13 over 6 units, or in terms of numbers, it is 3.00 units. That is a little bit better than 3 units. I repeat again. The radius of this circle that blocks triangle ABC equals to either 5 times square root of 13 over 6 units, or in terms of numbers, it is a little bit greater than 3 units. Okay, we finished with the first method. In the next step, I will present to you how to find out the radius of this circle that blocks triangle ABC according to the second method. In the second method, we will use the same things that we have already found out. We will rely on the things that we have already found out in the first method. So here from point A, we draw perpendicular on BC. Those two angles are equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as D. We have already found out that AD equals to 4 units, DC equals to 2 units, and BD equals to 4 units. In the first method, in the next step we will extend side AD by a straight line until it touches the circle. At this point we define the touching point of the extended side AD in the circle as E. Here we actually have rule number 1. Rule number 1 relates to two chords that intersect with each other inside the circle. So this is rule number 1. So here we have chord AB. This is chord AB. That intersects with chord CD. This is chord CD. I repeat again, chord AB intersects with chord CD at point O. Point O is the intersection point of chord AB with chord CD. Then according to rule number 1, if this is the data that has been given to us, then the following equation is true. That AO times OB equals to CO times OD. I repeat again, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We actually can implement rule number 1 in our drawing. Why? Because in our drawing we have chord AB and chord AE. This is chord AE that intersects with chord BC at point D. I repeat again, chord AE intersects with chord BC at point D. Therefore, according to rule number 1, we will get that AD over DE, AD times DE, AD times DE, AD times DE equals to BD times DC. Here, AD times DE equals to BD times DC. AD equals to 3 units. DE is the missing line segment, so we leave it as it is. And it is equal to BD. BD equals to 4 units times DC. DC equals to 2 units. So in conclusion, the formula that 3 times DE equals to 4 times 2, that is 8. Here we'll divide this equation by 3, and we get that DE, the missing line segment DE, equals to 8 over 3 units. DE equals to 8 over 3 units. We can write here that DE equals to 8 over 3 units. In the next step, I will present to you a second rule, and we will implement rule number 2 in our drawing. The according to rule number 2, if we have this circle, and here chord AB, this is chord AB, that intersects with chord CD, this is chord CD, at 90 degrees. They create with each other 90 degrees at the intersection point. So those two, all the angles around the intersection point are equals to 90 degrees. I repeat again, if chord AB intersects with chord CD at 90 degrees, we define the intersection point as point O. The length of side AO is A, the length of side OB is B, the length of side CO is C, and the length of side OD is D. So if chord AB intersects with chord CD at 90 degrees, then the following equation is true. That's 4 times R squared equals to A squared plus B squared plus C squared plus D squared. Okay? If chord AB intersects with chord CD at 90 degrees, then 4 times R squared. R is the radius of the circuit that contains the two chords. 4 times R squared equals to A squared plus B squared plus C squared plus D squared. Here we will implement rule number 2 in our drawing. First of all, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees, this angle must be equal to 90 degrees, and this angle must be also equal to 90 degrees because those two angles are complementary to 180 degrees. AE is the straight line, and the sum of the angles on one side of a straight line is equal to 180 degrees. So if one angle equals to 90 degrees, then the other angles must complete the sum of the angles to 180 degrees, therefore they must be equal also to 90 degrees. So if we know that all the angles around point D are right angles, for that reason we can implement rule number 2 in our drawing. Because in our drawing we have chord AE that intersects with chord BC at 90 degrees. Therefore, according to rule number 2, we get that 4 times the radius of this circle squared, the radius that we are looking for, equals to BD squared plus DC squared plus AD squared plus DE squared. So 4 times R squared equals to BD squared. BD is 4, so BD squared is 4 squared. This is 16 plus DC squared. DC is 2, so DC squared is 2 squared. This is 4 plus AD squared. AD equals to 3 units, so AD squared is 3 squared, that is 9, plus DE squared. D equals to 8 thirds, so DE squared will be equal to 8 thirds squared, that is actually 64 over 9. So in conclusion, we found out that according to rule number 2, 4 times the radius of the circle squared equals to 16 plus 4 is 20, and 20 plus 9 is 29. So here we have 29 plus 64 over 9. We'll multiply 29 by 9, and then we'll divide it by 9 in order to have a common factor with this expression. So here 29 times 9 is 261 plus 64 over 9. 261 plus 64 is 325 over 9. So we concluded we found out that 4r squared equals to 325 over 9. Here we'll divide this equation by 4, and we'll get that r squared equals to 325 over 9 times 4 is 36. (325) equals to 25 times 13, so we substituted 325 by 25 times 13 over 36. Here we take out of this equation, and we will find out here that r equals to the square root of 25 is 5 over square root of 36 is 6 times square root of 13 units. So in conclusion, we found out that the radius of this circle, the radius that we are looking for, equals to either 5 times square root of 13 over 6 units, so in terms of numbers it is a little bit greater than 3 units. Okay, we finished with the second method. In the next step I'll present to you how to find out the radius of this circle that blocks triangle ABC according to the third method. In the third method, we define angle ABC as theta, and we actually have a special formula to find out the area of any triangle. So if we have here triangle ABC, that could be any triangle. This is triangle ABC. And we know that this is triangle ABC. And the angle between side AB and side AC is theta. Side AB equals to A units in its length, side AC equals to B units in its length. Then the area of this triangle, triangle ABC, equals to A times B times sinus theta over 2. Okay, so we will use the new formula in order to calculate the area of our triangle, triangle ABC. According to the new formula, the area of this triangle, triangle ABC, we know that the area equals to 9 square units, but the formula is the formula for the area of this triangle ABC that is equal to 9 square meters, 9 square units. It will be equal to AB times BC times sinus theta over 2. So the area of triangle ABC that is equal to 9 square units, it is equal to AB is 5 times BC is 6 times sinus theta over 2. So 5 times 6 is 30 times sinus theta over 2. So we found out actually that according to equation number 1, 9 equals to 30 over 2 is 15 times sinus theta. Here we divide this equation number 1 by 3, and we get that 5 times sinus theta equals to 9 over 3 is 3. We will divide this equation by 5, and we will get that according to equation number 1, sinus theta equals to 3/5. Sinus theta equals to 3/5 according to equation number 1. We actually have the trigonometric identity that states that cosine theta equals to the square root of 1 minus sinus square theta. So actually, according to this trigonometric identity, we'll get that cosine theta equals to the square root of 1 minus sinus square theta. If sinus theta equals to 3/5, then sinus square theta will be equal to 3/5 square. 3/5 square is 3 square is 9 over 5 square, that is 25. So here we'll multiply 1 by 25 and then we'll divide it by 25 in order to have a common factor with this expression, and we find out that cosine theta equals to the square root of 25 minus 9 over 25. That is to say, cosine theta equals to 25 minus 9 is 16 over 25. So cosine theta equals to the square root of 16 over 25. Cosine theta equals to the square root of 16 is 4, and the square root of 25 is 5. So in conclusion, we found out that cosine theta equals to 4/5. Cosine theta equals to 4/5. So in the next step, we'll implement the law of cosines in our triangle ABC. So I will remind you shortly what is the law of cosines. What is the law of cosines? The law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. Side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. And the angle between side AB and side AC is theta. Then cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. I repeat again. We have a triangle ABC that could be any triangle. In this triangle ABC, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Okay, so here so we'll implement the law of cosines in our triangle ABC. In our triangle ABC, according to the law of cosines, we get that cosine theta equals to AB squared plus BC squared minus AC squared over 2 times AB times BC. So cosine theta equals to AB is 5, so AB squared is 5 squared, that is 25, plus BC squared. BC is 6, so BC squared is 6 squared, that is 36, minus AC squared over 2 times AB is 5 times BC is 6. So we actually found out that cosine theta equals to 25 plus 36 is 61 minus AC squared over 5 times 6 is 30 and 30 times 2 is 60. Here we multiply this equation by 60 and we get that actually here before that we already found out that cosine theta equals to 4/5. So we substitute cosine theta in this equation by 4/5. So 4/5 equals to 61 minus AC squared over 60. Here we'll multiply this equation by 60 and we'll get that 4/5 times 60 equals to 61 minus AC squared. Here 60 times 5, 60/5 is 12, and 12 times 4 is 48. So we found out that 48 equals to 61 minus AC squared. Here we add AC squared to this equation and we subtract 48 simultaneously, and we'll get that AC squared equals to 61 minus 48 is 13. So AC squared equals to 14. We take a root out of this equation and we get that AC equals to the square root of 13 units. AC equals to the square root of 13 units. So you can write here that AC equals to the square root of 13 units. Okay. In the next step I will present to you a new formula that gives us the radius of any circle that blocks a triangle, exactly like in our drawing. Here, this circle blocks triangle ABC. So the radius of this circle, according to the new formula, will be equal to capital R to the multiplication of the sides of the triangle that is blocked by the circle by each other. In this case it is AB times AC times BC over 4 times the area of the triangle that is blocked by the circle. In this case, triangle ABC is blocked by this circle, or triangle ABC is described by this circle. So it is 4 times the area of triangle ABC. In our case, it's triangle ABC, but triangle ABC could be any triangle. So this formula is valid for any circle that blocks triangle inside it, because triangle ABC could be any triangle. Okay. So the radius of our specific circle that blocks triangle ABC will be equal to AB is 5 units times AC is equal to 13 units times BC is 6 units over 4 times the area of triangle ABC. It is given us the question that the area of triangle ABC equals to 9 square units. So in conclusion, we found out that the radius of our circle that we are looking for is equal to 5 times 6 is 30, so it is 30 times square root of 13 over 4 times 9 is 36. Here we divide both the numerator and the denominator of this on this side of the equation by 6, and we get that the radius of this circle, the radius that we are looking for, will be equal to either, first of all, 30 over 6 is 5, and 36 over 6 is 6. So it is 5 over 6 times square root of 13 units. So the radius of this circle, the radius that we are looking for, equals to either 5 over 6 times square root of 13 units, so in terms of numbers, it is a little bit greater than 3 units. We finish with the third method. In the next step, I will summarize the lecture. Okay? We'll start, of course, with the first question. So here we have the big circle that blocks triangle ABC. Triangle ABC is inscribed by the big circle, and triangle ABC blocks the small circle. The small circle is inscribed by triangle ABC. The radius of the big circle equals to 13 units. The radius of the small circle equals to 4 units. Side AB is the diameter of the big circle, and we want to find out the shape and the area of the blue shape. Okay, so first of all, we define the center of the small circle as O. We define the point of tendency of tangent CB with the small circle as M. We define the point of tendency of tangent AC with the small circle as N, and we define the point of tendency of tangent AB with the small circle as L. Then we join points O and M together by a straight line. Point O is the center of the small circle. Point M is the point of the small circle itself. So this is exactly the definition of a radius. So OM is the radius of the small circle that is equal to 4 units. And we have rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius OM that is drawn to the point of tendency. That is to say, the radius OM, it is drawn to point M, that is the point of tendency of tangent CB in this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So if CB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Okay? Likewise, we join points O and N together by a straight line. O is the center of the small circle and is the point on the small circle itself. So ON is the radius of the circle. This is exactly the definition of a radius. So ON is the radius of this circle that is equal to 4 units. So here we have the radius ON that is drawn to the point of tendency, that is to say, it is drawn to point N, that is the point of tendency of tangent AC with this small circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NO. So if AC is perpendicular to NO, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Then we have the rule that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. So peripheral angle ACB, this angle, peripheral angle ACB rests on the diameter of this circle on AB, that is the diameter of this circle. Therefore, peripheral angle ACB equals to 90 degrees. So this angle equals to 90 degrees according to the rule that I mentioned, that any peripheral angle that rests on the diameter of a circle must be equal to 90 degrees. So this angle also equals to 90 degrees. So in quadrilateral ONCM, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the 4 angles, that is actual angle MON. This angle, in total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation, and found out that the missing angle MON equals to 360 degrees minus 270 degrees. It is equal to 90 degrees. So here this angle equals to 90 degrees. Therefore, inside quadrilateral ONCM, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral ONCM as a rectangle. Okay, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle ONCM, ON must be equal to MC, according to the rule that the opposite sides of a rectangle are equal to each other, ON equals to CM. But we have already found out that ON equals to 4 units. Here ON equals to 4 units. And from this equation 4 equals to ON equals to CM, we will derive that CM is also equals to 4 units. Here CM is also equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we will get that OM equals to NC. OM equals to NC. But we have already found out that OM equals to 4 units. So we can write here that OM equals to 4 units, and from this equation 4 equals to OM equals to NC, we will derive that NC is also equals to 4 units. Here NC is also equals to 4 units. So we actually found out that all the sides of quadrilateral on NCM are equal to each other, they are equal to 4 units, therefore quadrilateral ONCM is not a rectangle but a square. Then we define side AC as A, side CB as B, and side AB, that is the diameter of the circle, as C. So what is the length of AN? AN equals to AC minus NC. Again, AN equals to AC minus NC. AC equals to A, NC equals to 4 units, so in conclusion we found out that AN equals to A minus 4. AN equals to A minus 4. Likewise, we found out the length of line segment MB. MB equals to CB minus CM. Here, MB equals to CB minus CM. CB equals to B, according to our definition. CM equals to 4, according to what we have already found out. So in conclusion, we found out that MB equals to B minus 4. Here, MB equals to B minus 4. Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So if you focus on the common external point, point A, from the common external point, point A, we have two tangents to this small circle, tangent AL and tangent AN, and according to rule number 2, they must be equal to each other. So here AN equals to AN according to rule number 2. But we have already found out that AN equals to we already found out that here AN equals to A minus 4. We already found out that AN equals to A minus 4, and from this equation AN equals to A minus 4, we will derive that AN is also equals to A minus 4. Here AN equals to A minus 4. Then we focus on the common external point, point B. From the common external point, point B, we have two tangents to the small circle, tangent BL and tangent BM. And according to rule number 2, they must be equal to each other. Here BN equals to BM according to rule number 2. But we have already found out that BM equals to B minus 4. So we can write here that BM equals to B minus 4, and from this equation BL equals to BM equals to B minus 4, we derive that BL is also equals to B minus 4. Here BM equals to B minus 4, BL equals to B minus 4, and we already found out that AN equals to A minus 4. Okay? So actually, the diameter of this circle is AB, the big circle is AB, and the diameter of any circle is twice as long as the radius. So if the radius of the big circle equals to capital R, then the diameter must be equal to R. So AB equals to 2R, but the radius of the big circle equals to 13 units. So 2 times 13 is 26. So here the diameter AB equals to 26 units. So from one side the diameter AB equals to 26 units, but from the other side, from the drawing, it is very easy to see that AB is also equals to AL plus LB. Here AB equals to AL plus LB. AL equals to A minus 4, LB equals to B minus 4. So we substitute AL by A minus 4 and LB by B minus 4, and found out that 26 that is equal to B equals to A minus 4 plus B minus 4. That is to say 26 equals to A plus B, minus 4 plus minus 4 is minus 8. So 26 equals to A plus B minus 8. We added to this equation number 1, 8, and we found out that AB equals to 26 plus 4, that is 34. Then we squared this equation number 1, that is to say, we squared both sides of this equation number 1, and found out that 34 A plus B squared equals to 34 squared. We opened the brackets on both sides of equation number 1 and found out that A plus B squared equals to A squared plus B squared plus 2 times AB, and 34 squared equals to 1156. Okay, then we focused on the right triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. That is to say, AB square equals to AC square plus CB square. Here, AB square equals to AC square plus CB square. AB equals to C, so AB square is C square. AC equals to A, so AC square is A square. And CB equals to B, so CB square is B square. So in conclusion, we found out that C square equals to A square plus B square, but C equals to 26, so C square is 26 square. That is equal to A square plus B square according to equation number 2. So, according to equation number 2, we found out that 26 squared, that is 626, equals to A square plus B square. And because of the fact that A square plus B square equals to 676 according to equation number 2, it means that we can substitute A square plus B square in this equation number 1, by 676. We did it and we got here that according to equation number 1, A square plus B square is equal to 676, and plus 2 times AB equals to 1156. So according to equation number 1, 676 equals to 2 times A, 676 plus 2 times AB equals to 1156. We subtracted 676 from this equation number 1, and we found out that here 676 minus 676 is 0, so 2 times AB equals to 1156 minus 676 is 480. So in conclusion, we found out that according to equation number 1, 2 times AB equals to 480. We divided this equation number 1 by 2, and we found out that AB equals to 480 over 2 is 240. We divided this equation again by 2, so AB over 2 equals to 240 over 2. 240 over 2 is 120. So in conclusion, we found out that according to equation number 1, AB over 2 equals to 120. So what is the area of the blue shape? From the drawing, it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. Again, the area of triangle ABC minus the area of triangle, ABC minus the area of the blue shape, the area of triangle ABC minus the area of the small circle equals to the area of the blue shape. Again, the area of triangle ABC minus the area of the small circle equals to the area of the blue shape. The area of the blue shape equals to the area of triangle ABC minus the area of the small circle. So what is the area of triangle ABC? The area of triangle ABC equals to the base of the triangle that is AC times the height to the base that is CB over 2. The area of triangle ABC equals to the base AC times the a to the base, that is CB over 2, minus the area of the small circle. The area of the small circle is pi r square when r equals to 4 units. So here AC equals to A, CB equals to B. So in conclusion, AC times CB over 2 equals to A times B over 2 minus pi r square. R equals to 4, so r square is 4 squared, that is 16. So in conclusion, we found out that the area of the blue shape equals to A times B over 2 minus 16 pi. We have already found out that A times B over 2 equals to 120, so we can substitute A times B over 2 by 120, we did it, and we got that the area of the blue shape equals to either 120 minus 16 pi square units, so in terms of numbers it is equal to 69.73 square units. Okay, we finished the first question. Next step, I presented to you the second question, and we solved the second question in three different methods. The second question, we have this circle that blocks triangle ABC. Now triangle ABC equals to 9 square units, side AB of triangle ABC equals to 5 units, side BC equals to 6 units, and we want to find out the radius of this circle that blocks triangle ABC. Okay, so first of all, from point A we go perpendicular on BC. We define the touching point of the perpendicular from point A and BC as D. So this again equals to 90 degrees, and this again equals to 90 degrees according to our construction. So the area of this triangle ABC equals to 9 square units. The area of triangle ABC equals to 9 square units according to what is given as the question. And the area of triangle ABC equals to the base of the triangle that is BC times the height to the base that is AD over 2. BC equals to 6 units, so it is 9 equals to 6 times AD over 2. 6 over 2 is 3. So according to question number 1, we found out that 9 equals to 3 times AD. We divided this equation by 3 and found out that AD equals to 3 units. Then we focused on the right triangle ABD, and the right triangle ABD, the square of the hypotenuse equals to the sum of the square of the perpendiculars according to the Pythagoras theorem. That is to say, AB square equals to BD square plus AD square. AB square equals to AD square plus BD square. AB is 5, so AB square is 5 squared, that is 25. AD is 3, so AD square is 3 squared, that is 9. So in conclusion, we found out that according to equation number 2, 25 equals to 9 plus BD square. Here we subtracted 9 from this equation number 2, and found out that 25 minus 9 is 16. So 16 equals to BD square. Here we took out all of this equation number 2, and found out that BD equals to the square root of 16, that is 4. So we found out that BD equals to 4 units. Then what is the length of side DC? From the drawings is very easy to see that DC equals to BC minus BD. DC equals to BC minus BD, that is to say DC equals to BC, that is 6, minus BD, that is 4. So DC equals to 6 minus 4, that is 2. Then we focus on triangle ADC. We implemented the Pythagoras theorem of triangle ADC. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AC square equals to DC square plus AD square. AC square equals to AD square plus DC square. So AC square equals to AD is 3. So AD square is 3 squared, that is 9, plus DC square. DC is 2, so DC square is 2 squared, that is 4. So in conclusion, we found out that AC square equals to 9 plus 4, that is 13. We took out all of this equation and found AC square equals to 13, so we took out all of this equation and we found out that AC equals to the square root of 13 units. If AC equals to the square root of 13 units, then here from point A, we define the center of this circle as point O, and then we join point A and O together by a straight line, and then we extended line segment AO by a straight line until it touches the circle at point A. A is the diameter of the circle because it passes for the center of the circle, that is to say, it passes for point O, that is the center of the circle. Therefore, AE is the diameter of the circle, and the diameter of any circle is twice as long as the radius. So if the radius of this circle is R, is capital R, then AE will be equal to 2 times capital R. Then we join points E and B together by a straight line. Angle AEB, this angle rests on AE, that is the diameter of the circle, and any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. So this angle ABE, that rests on the diameter of the circle must be equal to 90 degrees. So here, this angle ABE equals to 90 degrees, according to the rule that I mentioned. Then we also have another rule that peripheral angles that rest on the same chord are equal to each other. Here, those two peripheral angles rest on the same chord AB, therefore they are equal to each other. That is to say, peripheral angle ACB equals to peripheral angle ABE because of the fact that they rest on the same chord. So if we define angle AEB as theta, if this angle equals to theta according to our definition, then from this equation angle ACB equals to angle AEB equals to theta, we will derive that the angle ACB equals to theta 2. Yeah, this angle ACB also equals to theta. So in the great angle ADC, this angle equals to theta, this angle equals to 90 degrees, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this triangle ADC to 180 degrees. This angle must be equal to 90 degrees minus theta. For the same reason, exactly, this angle must be also equal to 90 degrees minus theta. Then we prove that those two right-wing triangles are similar to each other. Why? First of all, those two angles are equal to each other. They are equal to 90 degrees. Therefore they are equal to each other. Those two angles are both equal to theta, therefore they are equal to each other. Those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually found out that triangle AB is similar to triangle ADC according to angle similarity rule, and from the fact that those two great triangles are similar to each other, we conclude that AB over AD equals to AE over AC. AB here, AB over AD equals to AE over AC. Okay, AB is 5, AD is 3, AE is 2R, it is the diameter of the circle, and AC equals to square root of 13 units. We multiply this equation number 3 by square root of 13, and we found out that 2R equals to 5 over 3 times square root of 13. We divided this equation by 2, and we found out that the radius of the circle that we are looking for equals to either 5 over 6 times square root of 13 units. On terms of numbers, it is equal to 3.00 units. We finish with the first method. Then I presented to you how to find out the radius of this circle that blocks triangle ABC according to the second method. In the second method, we found the fix that we already found out in the first method. Here from point A we do perpendicular of BC. This angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Here we know that from method 1 we know that this equals to 2, BD equals to 4, and AD equals to 3. Then we extended line segment AD by a straight line until it touches the circle at point E. Then we implemented rule number 1 in this drawing. According to rule number 1, if code AB intersects with code CD at point O, then the following equation is true, that AO times OB equals AO times OB equals to CO times OD. You can implement rule number 1 in our drawing, because in our drawing we have code AE that intersects with code BC at point D. Therefore, according to rule number 1, we get that BD times DC equals to AD times DE. Or according to rule number 1, BD times DC equals to AD times DE. AD is 3, DE is the missing line segment, BD is 4, and DC is 2. So if we found out that 3 times DE equals to 4 times 2, that is 8. 3 times DE equals to 8, we divided this equation by 3 and found out that DE equals to 8 over 3 units. Here, DE equals to 8 over 3 units. Then I presented to you rule number 2, and we implemented rule number 2 in our drawing. According to rule number 2, if code AB intersects with code CD at 90 degrees, the intersection point between those two chords is happening at 90 degrees, or the create between them 90 degrees at the intersection point. Then the following equation is true, that 4R squared equals to A squared plus B squared plus C squared plus D squared. Here we can implement rule number 2 in our drawing, because in our drawing we have code AE that intersects with code BC at 90 degrees. Therefore, according to rule number 2, we get that 4R squared equals to AD squared plus DE squared plus BD squared plus DC squared. 4R squared equals to BD squared plus DC squared plus AD squared plus DE squared. BD equals to 4, so BD squared is 4 squared, that is 16, plus DC squared. DC is 2, so DC squared is 2 squared, that is 4, plus AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus DE squared. DE is 8 over 3 units, so DE squared is 8 over 3 squared, that is 64 over 9. So we found out that 4R squared equals to 16 plus 4, that is 20, 20 plus 9 is 29, so 4R squared equals to 29 plus 64 over 9. We multiplied 29 by 9, and then we divided by 9 in order to overcome the factor with this expression. We found out that 29 times 9 is 261 plus 64 over 9 equals to 4R squared, so 261 plus 64 is 325. So in conclusion, we found out that 4R squared equals to 325 over 9. Here we divided this equation by 4, and we found out that R squared equals to 325 over 9 times 4 is 36. So R squared equals to 325 over 36. We substituted 325 by 25 times 13. So R squared equals to 25 times 13 over 63. We took a root out of this equation and found out that R equals to the square root of 25 is 5 and the square root of 36 is 6. So in conclusion, R, the radius of this circle, equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. Then I presented to you how to find out the radius of this circle that draws triangle ABC according to the first method. In the first method, we defined angle ABC as theta. And we have special formula for the area of any triangle. The area of this triangle, triangle ABC. The angle between side AB and side AC is theta, AB equals to A units in length, AC equals to B units in length. Then the area of this triangle ABC equals to A times B times sinus theta over 2. According to this formula, the area of this triangle ABC will be equal to AB times BC times sinus theta over 2. AB times AC times sinus theta over 2. And we know that the area equals to 9 square units. So 9 square units, that is the area of triangle ABC equals to AB, that is 5, times BC, that is 6, times sinus theta over 2. 5 times 6 is 30, so it is 30 over 2 times sinus theta. 30 over 2 is 15, so in conclusion we found out that 9 equals to 15 sinus theta. We divided this equation number 1 by 3, and we found out that 15 over 3 is 5, and 9 over 3 is 3. So in conclusion, 5 times sinus theta equals to 3. We divided this equation number 1 by 3, and we found out that sinus theta equals to 3/5. Sinus theta equals to 3/5. And we have the trigonometric identity that cosine theta equals to 1 minus sinus square theta. So cosine theta equals to 1, and sinus square theta, what is the value of sinus square theta? If sinus theta equals to 3/5, it means that sinus square theta will be equal to 3/5 square. 3/5 square is 3 squared, that is 9, over 5 squared, that is 25. So it is 9 over 25. So we found out that cosine theta equals to the square root of 1 minus 9 over 25. Here we multiplied 1 by 25 and then we divided by 25 in order to overcome factor with this expression, and found out that cosine theta equals to the square root of 25 minus 9 over 25. 25 minus 9 is 16, so it is 16 over 25. So cosine theta equals to the square root of 16 over 25. So cosine theta equals to the square root of 16, that is 4, over the square root of 25, that is 5. So in conclusion, we found out that cosine theta equals to 4/5. Okay, then we implemented the law of cosines in our triangle ABC. So what is the law of cosines? The law of cosines is true in any triangle. So if you have triangle ABC, that could be any triangle. The angle between side AB and side AC is theta. AB equals to A units in length, AC equals to B units in length, and BC equals to C units in length. Then cosine theta equals to A square plus B square minus C square over 2 times A times B. Implemented the law of cosines in our triangle ABC. According to the law of cosines, we get here that cosine theta equals to AB square plus BC square minus AC square over 2 times AB times BC. AB equals to 5, so AB square is 5 squared, that is 25. BC equals to 6, so BC square is 6 squared, that is 36, minus AC square over 2 times AB is 5, and BC is 6. So we found out that cosine theta equals to 25 plus 36 is 61, minus AC square over 5 times 6 is 20, is 30, and 30 times 2 is 60. So cosine theta equals to 61 minus AC square over 60. We have already found out that cosine theta equals to 4/5, so we substituted cosine theta by 4/5. And we got that 4/5 equals to 61 minus AC square over 60. We multiplied this equation by 60 and found out that 4/5 times 60 equals to 61 minus AC square. We added AC square to this equation and we subtracted here. Before that, 4 times 5 times 60 equals to 61 minus AC square. 60 over 5 is 12, and 12 times 4 is 48. So in conclusion, we found out that 48 equals to 61 minus AC square. Here we added AC square and subtracted 48 simultaneously from this equation, and we found out that AC squared equals to 61 minus 48 is 13. So AC squared equals to 13. We took out of this equation and we found out that AC equals to the square root of 13 units. Here AC equals to the square root of 13 units. Then I presented to you a new formula, and according to the new formula, by this formula we can calculate the radius of any circle that blocks triangle. In our drawing, triangle ABC is described by the circle, so this circle blocks triangle ABC, so we can implement the formula in our drawing. So the radius of any circle that blocks the triangle, it is equal to the multiplication of the sides of the triangle by each other. In this case is AB times AC times BC over 4 times the area of the triangle that is blocked by the circle. In this case, in our case, it's triangle ABC. So the radius of our circle that blocks triangle ABC will be equal to AB that is 5 times AC that is close to 13 units times BC that is 6 over 4 times the area of triangle ABC that is blocked by the circle. And the area of triangle ABC equals to 9 square units. So we found out that R equals to 5 times square root of 13 times 6 over 4 times 9. 4 times 9 is 36, so, and 5 times 6 is 30. So in conclusion, we found out that the radius of this circle that blocks triangle ABC equals to 30 times square root of 13 over 36. We divided both the numerator and the denominator of this equation, of this side of the equation by 6, and we got that 30 over 6 is 5, and 36 over 6 is 6. So in conclusion, we found out that the radius of this circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. Okay, thank you very much.